Hi, everyone. Welcome to our Innovators in Analytical Chemistry Education webinar for July, a week early. And we're excited to welcome today's speaker, Shannon Accettone. I'll introduce her briefly, but first I want to put in a plug for our August event, which will be with Dr. Gada Raba from North Carolina State University, who's going to be talking about designing curricula to prepare students for the workforce. So I'll put a registration link and a little more information about that in a chat at the end of the webinar, or maybe momentarily if I'm quick enough. But today I'm so excited to introduce our speaker. Dr. Acetone is from Trent University in Ontario, Canada. She's an associate professor there in a teaching intensive role who works on scholarship of teaching and learning and has been recognized with awards for her work. Today, she's going to be telling us about how she's been studying the use of mastery-based grading in analytical chemistry. And I'll stop there, Shannon, so you have plenty of time, so take it away.
Perfect, thank you. I see a few familiar names in the chat, Chuck, Krista, Gregor, a few others, so that's awesome. All right, so we'll get started. I do want to, right off the bat, acknowledge the two students who have been working on this project with me as well. So Cole Doris is a fourth-year student who's just graduated his honors bachelor in chemistry and moving into his teaching degree with us at Trent. So this was his honors thesis project that he started throughout this year. But of course, in scholarship teaching and learning, course-based things, the thesis is due before you get the information for term two. So his thesis focused on that first term, and that's what we're going to look at here just because of the case study that I've chosen. And then over the summer, Aidan O'Garrow has started working on writing this up for publication and bringing in that second semester information. So tracking the students across these two semesters of our introductory analytical suite. So I want to just start out by recognizing the traditional lands that Trent University sits on. While I don't live at the Peterborough campus, I live more closer to Toronto. The Trent, Peterborough, and Durham campuses are located on our traditional treaty territories of the Mississaugas, Anishinaabe, made up of Curve Lake First Nation, Alderville First Nation, Hiawatha First Nation, and the Mississaugas of Scugog Island. All right, so let's start things off. Let's look at traditional grading. This is what we kind of all think of when we talk about grading, what students are familiar with, what they think of first off when someone says, here's how you're going to be graded. You know, it's the first thing they look at on a syllabus as they scroll down to see how much is everything worth, how much work do they have to do. It's familiar. Little explanation is required for this model. It's a good quantifiable measure of performance for a student. It provides the students with a sense of progress. The calculations of grades are straightforward. You know, if I traditionally grade something and I send it to our administrative assistant and she needs to look something up, she can usually do that. Having just had her look something up in this course, she couldn't do it. I had to go in and translate the gradebook for her. And it's really efficient in large classes using these traditional models. And we'll talk about my large enrollment analytical suite for this. But if we're going to talk about alternative models and why we kind of end up in those alternative models, this is a lot of what people think about. Grades, you know, instead of a sign of excellence, grades are seen as destructive. They're not constructive. It's not taking the feedback and learning from our mistakes. It is, here is your one-time 42%. And that can really, really hit some students hard, especially when they're not used to those particular grades as they move into courses that challenge them to think differently than they often have before, which I feel like is very quintessential to at least my analytical course. It is structured very differently, assessed very differently. And the focus for me is on those higher thinking concepts, critical thinking, synthesis of knowledge. Oftentimes they don't have to do that previously. A lot of this is an extrinsic motivation piece too. The students are just sitting there trying to get the highest grade possible. They're point chasing. They're asking for those little 0.25s, 0.5s. Can I just get this? Or I don't think I should have been docked that. So there's not really this intrinsic motivation to just learn. One of the biggest things for me is this piece, the early mistakes, especially with the practical side of analytical, when we're looking at skill development inside the laboratory. Can they learn how to do this properly? which links really well to next month's webinar on workforce readiness of preparing people to go out into a lab. We can't expect them to get it immediately when, I go through and show them all these skills of how do you do this work without letting your volumetric flask cap touch the bench? I sit with it in my fingers, and that's a learned muscle memory thing that takes time for them to do. Same thing with the concepts. When we initially give them a concept, do we really expect them to get it immediately? So there are these penalties that can't be recovered down the road if we're traditionally grading and we have an initial assignment or an initial midterm. There's no really way to correct that loss of marks. And for the students, they now see no intrinsic incentivization to go learn what they didn't know because the points have already been lost and they just continue kind of clunking forward. Um, so this whole iterative process of learning from mistakes is penalized rather than seen as a mechanism for growth and learning processes as we go through. So this is kind of where everything came from for me to move out of this traditional model and into something that incorporates mastery. So this is kind of that overall piece of, in some ways, traditional grading can interfere with that intrinsic motivation for students to learn, and it turns it into a place of competition instead of creativity and discovery and learning. Now, is it perfect? No, there's never going to be a perfect grading model. And traditional grading does still have its place. So it's not that I would say we need to move, or it just really depends on the course context, its structure, to what makes the most sense for that particular course. So when we look at alternative approaches, mastery-based grading, and I'll talk about one other that are kind of synthesized together in my course. Mastery-based grading rewards improvement because we allow students to reattempt the work, take the feedback that we've given them, re-go through that process. So if we're teaching them how to pipette, they go through and it's, oh, you missed that step. The solution you've made is actually inaccurate now. It's not going to have the concentration you think it does. We can tell them that they haven't met the expectations of the course, but they can try again. Whether it be 30 minutes down the road, we don't let them try again immediately. Go practice, come back. Or is it all semester? So being able to take the feedback from the TAs, from the written feedback on assignments, and then actually incorporate that into their knowledge to resubmit something. So overall, when we look at the final grades that we calculate at the end of the term, they reflect the overall learning process rather than those individual points in time. And I always like how Chuck can manage to get an analytical thing into everything he talks about. And I think about this as kind of like equilibrium. It's dynamic, right? Your learning process is dynamic. It's not static. So we don't want to take those static moments in time and create a student's grade solely based around that. We want those dynamic pieces. There's always a challenge. So up front, there's a lot of time for feedback and remarking. So if you're going to let them resubmit something, you're essentially potentially doubling out your workload in grading. And then this can be compounded in large courses. So we're going to look at my course, it's not first year, it's second year for us. It's the first time they come into analytical chemistry. It's a year-long suite, and it has about 200 students. So it's fairly sized. So what I want to do here is just this idea of making the grading process an opportunity for learning instead of just of learning. That's when we're just summatively assessing what have they learned. And then sometimes we can get this idea of the assessment becomes part of their learning. This is what we want to get to. And I like this kind of quote that I've put together of a lot of first submissions students put together are inaccurate. They represent misunderstandings or poor initial concepts. They haven't gotten it yet. And it's this power of yet piece that mastery-based grading allows us to hinge on, giving them the opportunity to improve and actually go back and learn that content so that they don't just consider it a lost cause and move on from there, especially when so many concepts build on each other. And it requires you to know those threshold concepts of, equilibria to understand a whole bunch of other chemistry that's occurring. I'm going to briefly mention specifications grading here as well, and I won't spend too much time. I might click a little quickly through it, but my course is a specifications graded course as well. So it's mastery based inside of a specifications umbrella, which makes it a little bit harder. Um, so under specifications grading, we're looking at clearly defined learning outcomes for students, and it's assessing their ability to either meet or not meet those. So if we look at the concept of pipetting, I'm going to hinge on skills here for a second because we'll stay lab related for the talk. Can the student pipette or not? Do they meet what we would consider a second year level of pipetting? So we could indicate that yes, they have met the expectations or they haven't. So it takes away the fine graining of traditional grades where if somebody were to pipette in front of you, how do you assign them a grade out of 10? Like, was that pipetting an 8.2? Or was the pipetting an 8.6? Like, are you giving them an 82 or are you giving them an 86 on their ability to pipette? From my standpoint, they either did it or they didn't. The solution they made is accurate or the solution they made is wrong. And they're going to have issues downstream in their analysis. So it takes those specifications and grades on those. And it works really well because mastery grading is often incorporated into this naturally. From a disadvantages side, students are very confused when you pop them into a specifications course where they've never seen one before. It's a very unfamiliar system for them. And we don't have an all or nothing structure in my course, but this idea of meeting or not meeting the expectations is super stressful for them. It's very odd that they would rather get a 32 than a does not meet expectations, which has blown my mind when we've been going through the data for this, that they would rather have the clearly failing points-based grade than something that just says you didn't meet the expectation. I don't know. Not meets expectations seems a little bit softer to me than a 32 showing up as a grade. And because of the way that STEM courses work, this is often really hard to incorporate into STEM-based courses. We have a lot of course components, lab versus lecture components in one course. So it can actually be a little bit challenging, and that's kind of where we've found as well. But just really, really quickly, one of the ways to go through the specifications grading is to kind of take certain portions of the course as essential. What do the students have to pass? How much of it do they have to pass? And a lot of it sits on this idea of the higher the grade they want, they either have to achieve more hurdles, so they have to do more stuff. The more stuff they do, the higher their grade goes, or you can grade them on higher hurdles, so more challenging work. And here's just an example on the simpler of the two of just grading on more hurdles. You could get a C in a course if you completed module 1, but to get a B, you have to complete modules 1 and 2. And then to get an A, you have to complete all 3 modules to that satisfactory level. So you can't fail them all. You would need to meet the expectations of that particular module. This one's a little bit more complicated. So these come out of this book here by Linda Nielsen, just as examples, where this one is more plus higher. So you'll see that it's adding towards the top there, towards A. They're going to have to prepare and teach 2 chapters, but they also have to complete a final project. And that final project is only required if you want a B or higher. And then it has to be at a certain level of quality in order to get into that A side of things. So this is what a traditional course could look like. We're going to look a little bit at what my course looks like. So I'm going to focus on the mastery-based piece of the course, but of course, everything is graded under the specifications umbrella. So that will be important to consider as we look through. Again, this is a fairly large enrollment introductory analytical course sitting in our second year level. So after they transition out of first year with its general chemistry, in second year, they get introduced to the individual disciplines. Analytical chemistry now, as of the last 2 years, is a 2-semester course. So part 1 and part 2 across the full second year. So here's the 2 courses here. I'll just call them analytical 1 and 2, but 2410 and 2420. So the way that the course is set up and structured, it is on a hybrid specification system. I actually chose to go with a 3-point pass-fail system instead of just pass-fail. This allows us to differentiate those students that are sitting at the very top of the class who don't want to just see a pass. They want to know that they are at the top. So we have unsatisfactory as a not meeting expectations. Pass is our you have met the expectations of our second year course. And then mastery is our you have exceeded the expectations of a second year course. These are our 90s students. This is what they would be aiming for. So this way we can allow those 70s students and the 90s students to be differentiated a little bit. And it does come out in the kind of laundry of the course. What I also did was decouple the course components. So instead of having these buckets where you had to hit, so for example, here's the crazy thing that I give my students on how you're going to get your grade. It takes a little while to explain it to them. But a lot of times it would be, in order to get an A, you have to meet the requirements of the A all the way across the table. If we think about an analytical course and where the students tend to struggle the most, at least from my experience, we don't want to penalize a student who has great lab skills, great quizzes, their assignments are pretty good, but they can't get the accuracy in the lab to save their lives. They cannot get the right data. So this way we can actually have a student that looks like this, where they have done really poorly on the accuracy side of things. They've managed to only pass 2 of the 6 lab accuracies, but they've done really well on their lab skills. They're pretty solid on their reports and assignments. They're really good at those quizzes. We want to be able to delineate and reward their progression or their learning in individual portions of the course. So kind of like traditional grading has that. And then we do have a way for them to get 100 if needed, because the grade percentage applied, that second column, you'll notice caps out at 95. It's the middle of our A+ bracket. So they want to know, how do I go up there? This is an optional grade qualifier assignment, so they don't have to do it. But if they do, it pushes them from the middle of the bracket to the top of the bracket, depending on whether they pass or master it. These are usually based on the skills videos that I have published before. So we have our 3 components. We also have built-in mastery opportunities. So for their lab skills, they can request reevaluation for their lab skills at any point during the semester, so long as the skill exists inside of the lab they're doing, which we tell them exactly which skills they can get evaluated on when, and we make sure that they know when that skill is the last time they will use it in a particular lab. So when they're done titrations, they can't get those titration skills anymore. When is the last time they'll be pipetting or working with quantitative transfer, weigh by difference skills? So that's unlimited. The lab accuracies. So this is our, mimic of the real world in a proficiency test in an accredited laboratory environment of, here's your unknown, tell us its concentration. And we will grade you based on whether or not you got the correct concentration. But instead of scaling out from, that true value to lower and lower, we just decide, okay, what would we expect a second year student to obtain? That's our pass. And then anything exceeding that would be our mastery. And we have doesn't meet expectations for the unsatisfactory. So what we've done is build in 3 resubmission attempts for these. So there's 3 attempts total. They submit once. We give them their feedback. And like most universities, except ours aren't cue cards. I handed stuff in on cue cards as an undergrad. We'll tell them if their calculation's wrong. So instead of marking them to a 0 because the calculation is wrong, we actually punt it back to them and say your calculations are wrong, and we give them a little bit of feedback. Now they can reattempt. So they have 3 submissions total to use the feedback to get the calculation right, so that we're not grading them on an incorrect calculation and that reported value being obviously wrong because they've used the wrong stoichiometry, or they've shifted decimal places in a volume transfer or something, or they report without units. Now we're giving them the chance to fix those errors. So 3 submissions on that. They have little short theory quizzes at the end of each week. Those 3 attempts, And then technically they can improve their midterm exams with the final if they show improved learning. And then from the specifications piece, we also have a token economy. They can redeem a token that I give them. They're fake in our LMS. I take their token away, and then they can resubmit questions from their lab reports or from their assignments that they've done. But because those take a lot more grading capacity, we can't have unlimited or very large amounts of resubmissions on those. So in this case, they redeem a token. They can only do this if they originally got unsatisfactory, so they can't improve a pass, but they can take an unsatisfactory to a pass, and we cap them there. So I'm going to do a little case study of the accuracy component of the course because it is confined to our first semester. So we had all of that data already ready to go. And I find it a very interesting aspect of what we learned from the students. And I find accuracy is very unique to an analytical course as well. So I'm going to walk you through the data here. So here's lab 4. This is a simple acid-base titration. It is a strong titration. It's just sodium hydroxide and HCl. It's a 1-to-1 ratio. It is the easiest titration we can give them. So in this case, they're learning how to standardize. So for this one, it's their first accuracy. And you'll notice if you look at the colors of the submissions, the entire pie chart is basically gray. That means we punted it back to them for a calculation error. So only 17 students calculated correctly and were given an accuracy grade. There's a teeny tiny little 1 there. That is one student who calculated it correctly but was wicked outside of the range. So they got an unsatisfactory because they earned it. So then these gray components, they're the ones who can resubmit because they had a calculation error. So this is submission 2. Now we can see half of them still have the calculation wrong. 28 of them managed to get the calculation right, and we gave them their accuracy. They passed or they mastered. 3 of them got the calculation right, but were outside of the range. And then 42 of them, just over 1/4 of the students who could resubmit, elected not to do it. They gave up, which blew our minds. It is free marks to just learn the calculation. So then we took the half that were still incorrect, popped it out again. We have 1/4 of those students who are still getting it incorrect. They never got the calculation right, despite the feedback. Oddly enough, they also don't come to office hours. They just kind of like change a bunch of stuff in their Excel file and send it back to us. But we did see a chunk that were able to catch the calculations. Most of them passed. And then again, almost half of those 42, 31 of them gave up. So they did the second submission, but then didn't bother to do the third. And we kind of see this trend continue. If we move out to lab 8, this is the last titration they do. It's potentiometric. So it's actually the same thing. It's a strong titration, 1-to-1 ratio. The only difference is they have to do it with the derivative curves. And we see almost the exact same trend go across. Like it's almost perfectly the same of how many students are giving up as we go through this process. And we can take the 2 titration labs and take a look. This is the overall data. So almost half of the students are giving up by the end and not getting the calculations correct. Any kind of blue, they've gotten the calculation correct and obtained a pass or a mastery grade. The small gray chunk is the ones that never got the calculation right. And then the light red are the ones who got the calculation but were outside of the range. And the students who gave up, it's the same proportion. They're not all out of the range. If they got the calculations right, they would have gotten a grade. It wouldn't necessarily be unsatisfactory for the actual accuracy piece. We could look at it again for our calibration labs. So this was lab 9 last year. It's the first calibration, the 5th accuracy lab they do. This one is an analysis of iron in water. It's a colorimetric, so we're reacting it with gallic acid to create a nice pretty blue color. We like to have the colorimetric version so that they can kind of understand the progression of the standards. They can see the progression of the standards. You can stick the unknown somewhere in the middle and go, oh, it's between these two. So we like that visual aspect. So this is the first time they've ever been asked to do a calibration analysis, including the 95% confidence interval. So they do have to do that line est regression. Good chunk of them have gotten it, 42. It's like just under a quarter of the class. This is after I did a full hour workshop on how to do this. So still 75% of the course not quite getting there. If we kind of move those bubbles out again, it kind of looks the same, but it's not quite as dire as the titrations. We're still seeing a lot of students give up progressively, though. Nicely, when we did the next calibration, it's just 1 week later. This one's a caffeine analysis, so everything's clear and colorless. This one, they're starting to learn the calculation. So we actually saw a really nice improvement in comparison to the titration. And the reason I chose those two to highlight is it's essentially the exact same titration. 1-to-1, strong, strong. It just adds that potentiometric piece in the derivative curves that they have to calculate. So we see a lot less in this piece here, but still, the ones that have the calculation errors are giving up at a pretty high rate. So here's that overall look. We're still getting about a quarter of the class giving up entirely on getting these calculations right. So we broke down the usage here in after the initial attempt for the students who could resubmit because they got an unsatisfactory. We tracked out what percentage of them resubmitted and what percentage of them didn't. So the blue line is the ones that chose to resubmit. And then the red line is the ones that chose not to resubmit. So we're seeing a higher average of students electing not to redo the calculations than we are taking the opportunity to use the mastery-based attempts. And it's the same thing when we go through that extra attempt, so the third submission. They sit about 50-50. So half the students are electing to retry and half of the students aren't. I had Cole, as part of his thesis, he took a look at the students' grades and whether or not they improved. So in the green, it's actually tracking if they resubmitted, did they improve their grade? And if you look, like 70% or higher, they are improving their grade because at the end of things, it's not their accuracy that is the major problem. It's the calculations that are the major problem. So we asked them at the beginning of the term, or at the end of the term, why did you use the mastery-based attempts? And coded them out in an iterative process. And this is kind of what we came up with. They're not the best codes yet in terms of language. We're still working on this, but 56% of the quotes, and we double coded the quotes. So some quotes were long and they have multiple codes assigned to them. But 56% of the quotes were talking about, I was aiming to get that calculation right, which is great to see. Because if they are reusing the submissions, they are attempting to get that learning process of, I'm getting this calculation right. 52% of them we coded into some type of reflective learning. They were specifically mentioning using the feedback from the TAs. No surprise, 48% of them just said, I wanted a higher grade. It was interesting that it wasn't higher than that. And then we had a couple codes that were just, general improved understanding. They just said something like, I wanted to learn it better. And then there was a few students who said, I wanted to know my in-lab accuracy. Did I actually do it correct? And you won't tell me until I get the calculation right. So I need to get the calculation right in order to get that information off of you. So there's a few quotes here from the students that we pulled from, not necessarily coded out into these specific categories. They'll hit multiple categories, but just ones that show that reflective process, wanting to understand where I went wrong, understand the topic, using the comments from the TAs. The first calculations aren't going to be correct. Doing the resubmissions helped me improve the approach to each accuracy question. And there was a couple of these spots where we saw it, where it almost lessened their worry about getting the calculation wrong in the first place. They did it, but they weren't 100% sure it was correct. They just submitted it. and then waited for the feedback to see where they went wrong. Um, so it's interesting to see kind of what they were saying from that perspective. The flip side of why did you not choose to use the mastery opportunities for the students that gave up? We had almost no responses to this question. There was, I think, 3 responses total. One said I was lazy. That was the sole comment. One indicated, I just had a really bad time with this semester. I was not in the mindset of school. I was not in the mindset to keep redoing things or reattempting. You're lucky I did it the first time, kind of thing. They were just in a bad place. Um, they do have that piece there, though, that if I had the time again, I'd do it. It's free marks. Um, and then this piece, I think we saw more anecdotally through conversations with our TAs, was that sometimes they got discouraged because even if the calculation was correct, there was that chance that they did get the unsatisfactory because their accuracy was incorrect. So a lot of them saw this process as not worth the time and effort to continue resubmitting for the potential of getting an unsatisfactory anyways, solely because their in-lab accuracy was too poor and it was outside of the acceptable range from that true value. Um, which is interesting. The third response is the one that we're kind of hinging on right now because students always ask about these real world applications. And here's your real world application. We are assessing you like a proficiency test in an accredited laboratory. We talk about QA/QC in the course, but they don't like it. And I said, but at least your job isn't riding on this right now. We're trying to show you, are you inside of those ranges? Are you outside of those ranges to give you feedback on your in-lab piece? Um, but they don't think they should be graded like that, which is odd because I didn't blink an eye at it in school. I kind of just accepted that that was how things ran. But I think they question us a little bit more in this generation than I would have questioned before. So they have no real intrinsic motivation to get the calculation correct if they feel that the accuracy piece is going to weigh them down. They're like, why put the work in? So they don't have that piece of maybe I should learn this calculation because I would need to do the calculation in a workplace setting. So that's their usage of the mastery piece. So they're using it, but not as much as I had hoped. Does bring the grading down a little bit because not everybody is resubmitting. And we saw this across every single aspect of the course. So assignments, lab report questions, it's kind of 50-50 whether or not they resubmitted it if they could. So we have all of the data to show that as well. But we wanted to ask them a few things about these mastery opportunities as well. So what was their perception of things? And we broke this down. They're Likert questions. So this one was, I believe, the opportunity to resubmit accuracies due to calculation or reporting errors improved my learning outcomes related to the laboratory calculations. So we're looking at, do you think you learned this better? And like it's pretty highly skewed to the strongly agree and agree side of things. It was very interesting to see the lack of office hour attendance, though, for those that were getting those calculations incorrect. I've seen a steep drop off on the use of office hours in this course specifically. And sometimes the work, the initiative, it's on them. They have to come and get that help. We talk about office hours constantly, but I can't make them come. So that piece is a little bit frustrating. So this was kind of some of what they said for this. My fire alarm might go off in a second from welding. Hopefully Zoom can cut out. I think the bottom one is a really important piece of I never learned how to complete the calculations or what I was doing because the feedback wasn't necessarily there but they did I missed my units. I found it to be rigorous, but the flexibility allowed me to make these stakes to correct. And I like this, small but important errors. It's important if you don't have a unit or you're missing a confidence interval or your confidence interval has 16 decimal places for some reason and your answer has 1. We tried to avoid those kind of things. Then we asked them about whether it provided them a higher motivation to actually complete the calculations correctly. Drops off a little bit here. And here's some of the what the students had to say. So this is where we really see but I kept getting my calculations correct, but my true value or my accuracy value gave me, and they're calling it a U. That's the unsatisfactory. It's how we put it into the learning management system is we just put a U. So between that and things like the feedback not being fulsome enough for them to understand what went wrong, but again, they're not coming to office hours to fix that either. Um, so it didn't have quite as big an influence on motivation to complete the calculations. The motivation was provided by the potential accuracy result, I think, in these cases. And then the last one, kind of surprising in this one, did it alleviate the anxiety and the stress associated with being graded for your in-lab accuracy? And we saw a lot more no's here because they were still worried about that. Yeah, sure, I can resubmit it, but you're still going to give me a U when my accuracy is wrong. So the student voice of those who were getting those unsatisfactories is quite high when we look at the survey responses, but it does tell us something. But they still did like knowing that they could resubmit. They just don't like that it doesn't have part marks. There was no, oh, you got the calculation correct, but here's your accuracy grade. So pieces like that we're going to take into consideration. And we asked them, and this is the whole course, not just the accuracy aspect of things, but what they thought the benefits of the mastery opportunities were across the course. And we coded these out as well. And the codes there are percentages for pre-analytical one. So this is before we did any work, fresh, bright-eyed. And then post-analytical one, so this would have been in December, and then post-analytical two, which would have just been this past April. And we did see a big piece about these additional attempts allowing them to have a lower stress and anxiety response to the course because they could retry. It wasn't that static end all be all, I submitted it, did poorly, and can't recover it situation. The piece of improving my grade went up consistently across the year, more and more. They just did it so that they could get their grade up. But we did still see a high level of reflective learning, that they were learning from the mistakes that they were making. They were taking in the feedback and applying that feedback. So it's a little bit of, a two-edged sword. Definitely they're focused on the grade component. They want a higher grade, but they are actually using the mastery opportunities in these resubmissions to do a little bit better. Learning from their mistakes, focusing on understanding the material rather than just the grade. It encouraged improvement. It helped me build confidence in applying the concepts. So I really like seeing some of these types of quotes. We did ask what they thought the challenges were. Interestingly, in the pre-course survey, and I think this might have been their understanding of the grading scheme, there was a fair amount, 31% of the quotes actually talked about this, I must achieve mastery. It was this high pressure to obtain the highest possible grade in this 3-point scale. So getting them to understand that actually it's a pass that you're aiming for. Mastery is for exceeding the expectations. You only need a bunch of masteries if you want a 90 in the course. Well, if it was a points-based course and a traditionally graded course, you'd have to do the same thing. You can't make mistakes and walk out with a 95. In this course, you can, because you can make mistakes and learn from them. So maybe I have to explain it a little bit better. But yeah, we saw this increased pressure piece that dropped off after they actually experienced the course. There's a little bit of the workload increase, this idea of I'm keeping up with the current assignments, but now I have to resubmit the old assignments. So not only is it extra work on me as an instructor or my TAs who have to regrade things, but it's a lot for the students as well. And that kind of hits in that first quote that we saw. It's challenging to balance the new stuff with the old stuff that they want to resubmit. So some people just said it's not worth my time in some of the quotes that aren't part of this because we didn't see them in the accuracy component. And there was quite a lot of students that just said, nope, there's no challenges. So, they really do like the system. Unfortunately, they're not using it at the level that I would like them to be. There's definitely some students we could target a little bit more. But if we think about everything kind of as a whole, um, a good chunk of the student body is electing not to reuse the submissions, um, which was surprising that, sometimes we were sending back an accuracy and the only error that it said was your significant figures are incorrect. They had to backspace 1 decimal point, or you have no units or incorrect units. And that was the only reason it was being returned, and they chose not to fix that error. And it was a 3 week period. So all of the resubmissions had to come in 3 weeks after the original deadline. So they had lots of flexible time to redo these kind of things. It wasn't a very quick turnover on them. So a lot of the frustrations from the students came from completing the calculation correct, but then still getting unsatisfactory, which across the term maybe reduced their motivation to keep doing that. So once they kind of got 1 or 2 of those back, they kind of said, never mind, I'm just not going to do it anymore. So one thing we're going to do, I'm not sure how I feel about this yet, but I am going to separate them. So it actually removes some of the real world application, makes it less real world, because we will grade them twice. We will open the accuracy submission. We can see immediately what their accuracy grade is. We will give them that grade. But then the calculation piece will be a separate grade so that the accuracy component is not stopping them from learning the calculation, because I still think it's important that they can actually manipulate the data, especially if it's a one-to-one titration. I don't think it's asking too much. So this way we can kind of decouple that and hopefully put the motivation back into getting the calculations correct. I keep thinking about it, and this is how I'm going to frame it to them. I was like, sure, you know what? AI is getting better at these calculations every day. But ultimately, if you certify the water safe to drink because the AI did the calculation, who's liable? Is it the AI you fed your data into, or is it you? You need to be able to troubleshoot these calculations as well. Um, there was a lot of feedback things. So again, it's like corralling cats. Getting the TAs to give consistent feedback across. I have very, very many TAs in this course. Um, but a lot of the student comments were like, I wanted them to tell me how to do it. So we have to balance walking them through the calculation step by step and feedback that guides them to that correct piece. Um, but when they are using the mastery opportunities, their grades increase. It is benefiting the grades. These minor errors, misconceptions, we can maybe get them to stop making them because we allow them to correct them. And then that process of correcting the error kind of embeds the learning back into that learning process of how do we do things. And this way we can create their errors in the accuracy instead of just reporting errors. Eventually they stop doing the reporting errors. They eventually get the significant figures on a 95% confidence interval correct. That's what we want to see, because it is an important piece of the work environment. My friends in industry say, I kept getting my thing handed back to me at work because my sig figs were wrong. And I was like, see, it's a thing. And we want them to learn that here where it's low stakes. It's not part of their job experience. So I'll stop there. And if anybody has questions, I'd be happy to answer them.
Maybe I can ask the first question, Shannon. Actually, go ahead, Gregor. Yeah, please do.
Thank you so much. That was really interesting. Really appreciate it. Regarding the poor rate of return and students kind of reattempting, might this be simply an economic decision in view of the other coursework that they have?
Yeah.
From an advising perspective, I sometimes say, well, look at when students are unhappy about performance of a certain task in a course, look at how much it really contributes to your final grade.
Mhm.
And isn't it better kind of to move on and focus on the other tasks at hand? This might kind of backfire here in the sense of that students are
Yeah.
simply making an economic decision and say, I don't care if it's 1.8 or 2%. towards the course grades, so I
Hmm.
won't bother. The second comment that I might have, you have mentioned this with the AI, that some students are simply lost because they're doing it with AI and they don't really understand and then don't want to put in the mental load to resubmit
Yeah.
where they would actually need to understand what's going on.
Yeah, and we did. So I focused down on the accuracy piece. We have a little bit more responses of the why didn't you resubmit for some of the lab reports or um, the mini assignments that we did throughout the term. So we have a little bit more data there where it's definitely this checks and balance thing that they're doing in their heads of, diminishing returns, whatever else. It's twofold. One, the balance of workload with other courses and things like that, they just don't have the time. We did have the odd comment in, I think it was the mini assignments that said, like, I've already hit this bucket of the specs grading, like I'm in the B. To get one more pass or mastery won't really change the bucket that I'm sitting in. I'm stuck at a B because I don't have enough assignments now that I can push upwards. So then they just say, well, it's not worth it because I can't change my overall grade. I think some of them decided that a little too soon, where like had they continually done the resubmissions, they absolutely would have changed their grade. But we're definitely seeing kind of that piece of it's a do they see the value, the worth of resubmitting? And it's why we give them so long to resubmit as well, to give them the flexibility of our current coursework plus other coursework. It's not a very fast turnaround. We do give them some time to make sure they can think through things again.
There's a question in the chat, and then I do see you, Chuck. In the chat, Zoe is asking, I think it was on slide 11, you showed a grading matrix and discussed an example of a student with low accuracy and good performance otherwise. And the question is, what grade would that student have received in that case using that matrix? Just curious about how that balances for overall grade.
Yeah.
Yeah, this one.
So it's a little bit weird. It took a while to get at it. I adjusted it at the end of the term. Like it's an evolving process. Um, you can't see my mouse, can you? You can?
We
Okay,
can see it.
cool. So let's say that the ones highlighted with the blue boxes were what a student accomplished. And because of their calculations, the average in the lab accuracy was very low because a lot of them gave up. So let's say they managed to pass two of them of the six. So that sits them at a 57. The lab accuracy, and this is where the hybrid piece comes into play, the lab accuracy was 15% of the course. So you get a 57 on 15%. But they were able to show pretty good lab skills in the lab. Usually those correlate, but calculation errors pull the accuracy down. In this case, they passed all nine skills and mastered eight of them. So there was one thing that they just couldn't master, but they still passed it. That sits them in this A bucket. The middle of the A is 87. So 87% of the 10% that the lab skills get. So it is still broken down into individual pieces where they don't have to hit, the A for the entire course to get an A. Sometimes you'll see a specifications course where the lowest bucket pulls your whole grade down to that bucket. We can't do that on something here, especially because of the accuracy, especially when the calculations are part of the accuracy and they're giving up. They'd all be pulled down into this D bracket when they really should be sitting maybe at a 65, low 70s from a holistic course perspective. Hopefully that helps with that.
Great, thanks. Chuck?
Okay, sorry. Um, Shannon, that was great. Thanks. I'm disturbed by the high percentage of students blowing their calculations.
Yeah.
One thing we found particularly effective, rather, I would lecture them to death on calculations and they'd blow it. We gave them in-class assignment where we gave them data and then they had them work in groups.
Mm-hmm.
And we graded those, but you could alternately tell students, okay, your group got the right answer. You can leave early. We then did a second one where we gave them a lab which was written up with an error. swapping sample and standard weights or using a wrong molecular weight, whatever, and had them go through that. And we did both of those before the first lab submission date. And that really improved reduced the calc errors.
Yeah, and we do example calculations through things, but it might be worth, I'm trying to add some stuff in this year to help with this critical thinking issue that we're seeing as they offload all their cognitive load onto AI, doing in-class things like this. And one of the ones I want to do is we actually had an issue with Lab 6. It's actually one of the ones from the QCA book. It's titration, but it's a two-component mixture titration of bicarbonate and carbonate. And I like that because I want samples that aren't super simple. Like, sometimes there's multiple things. So it combines a direct titration with a back titration. And one year it did not go right. And I had to troubleshoot what had happened. And it was actually the precipitation solution, the barium chloride. Instead of a 10% solution, it was a 1% solution that the technician made. So we didn't precipitate everything out. So now they're titrating way too much. I'm actually going to use that as a case study this year for them to think through, like, what could be the problem in this case, and hopefully they can go through that. Just trying to work these things in so that the calculations are a little bit better going forward. Because, yeah, it's a crazy amount of people getting it wrong. Even when we think of just super simple calculations, before we get into back titrations, before you get into multi-component titrations, before you ask them to do the speciation of something or buffers or whatever it happens to be, yeah, definitely the calculations need some support.
Gregor?
Yeah, just one more thought regarding the time that they have in order to redo some of the work. You said 3 weeks, if I'm not mistaken.
What we did was all the
With
resubmissions
lab
for
deadlines as
accuracy.
well, and there's some lab reports that have ample time to be prepared. And
Yeah,
sorry?
so the accuracy would come in on their lab day, and then all their
Yeah.
resubmissions would have to come in by the end of 3 weeks later.
Yeah, exactly. And I've also kind of reviewed lab submission dates, and anecdotally, the lab supervisors told me that students would start late anyway. So I'm wondering if kind of moving this up and say you have 1 week where it's still fresh, where they're not in another phase of the course of the term with all their other
Hmm.
courses, that where they would then simply say, I won't bother. This is not present in my mind anymore, to move up the deadlines so that they redo the work
Hmm.
when it's actually fresh, especially if only minor corrections are necessary, like fixing stick figs. You would be able to catch those. I don't know.
Yeah, it's definitely a possibility. I work in time as well for my TAs to go back in and regrade. So it's that process of how long does it take the TA to give the feedback? How long does it take the student to resubmit? TA give feedback, student resubmit, TA give feedback. So I think it might be possible. I'm restructuring a few things. I'm taking out a lot of things that were just everything was coming back to me as AI. Students getting really, really strong grades in their assignments and then getting an 8% on their final exam because they can't do the work themselves. So it might actually free up some of my time, where if I was doing a lot of this with the time I used to spend on other things, then maybe we could speed the timeline up too, because I'm supporting the TAs from underneath and kind of going, okay, let's go. And then that might be able to shrink it so that the calculation is fresher in their mind and they're still kind of thinking about, okay, here's this just direct titration before, 2 weeks later, they're into this back titration mixed with something else, or they get too far down and now they're doing speciation calculations. Um, and yeah, just the mixing of the different components of the course concepts, that kind of thing might be able to tighten it up.
I had kind of a related question or stuff I was thinking about, Shannon, related to what you said about office hours and how office hour attendance is down. That's something we've seen at my institution as well, especially in larger introductory courses. And we've seen it across the board, lower for office hours for chemistry students, lower for going to our math support center, lower for accessing our research librarians. And the idea is probably that it's AI, students are using AI instead of going to talk to a human. So I think there's potential for a really interesting like survey study of this phenomenon across institutions. But I did wonder a little bit about what do you think about maybe rebranding? I've seen some faculty rebrand office hours as um, like this is a resubmission workshop for these learning goals or these activities. And then if you schedule it, you sort of do what Gregor was saying, like bring their work on their effort on that forward in time and maybe allow for some scaling instead of writing detailed feedback to a lot of students on common errors, offering like the same feedback to a group of students, and maybe the
Hmm.
rebrand might encourage them to come. I don't know. But this question of office hours in the environment of AI, I think is an interesting one. If you have any thoughts.
Yeah, and I use the fourth year cohort that just graduated. When they were in analytical, this was, just before the AI takeoff. The lineup for my office during office hours went down the entire hallway. So every single faculty member couldn't get into their office because the students were standing and sitting in front of them. They were so well attended. I had to have something like 10 hours a week of office hours. So they were there all the time. And it was really good. They got those components of like, okay, I just needed to talk through with a person. And it's just not happening anymore. I've considered booking a room to hold office hours in so that it could be larger cohorts of students and we could do it more like that. Unfortunately, we don't have the space resourcing or something like that. It's really hard to get any type of classroom space outside of. I added a fourth hour to this course this year to up their contact hours as like a seminar, kind of like this. Here's some questions. Let's think through them. Here's a case study. Let's think through it. I'm not sure they'd give me any more classroom time. I'm using all of it. It's a big class, so I have to have a big room.
Yeah.
So I take our second largest room on campus for this particular course.
There are some great comments in the chat as well. Any other questions for Shannon?
I was just wondering if Zoe or Kim could elaborate on their comments.
Oh, we're just seeing this. I'm guessing this is what you're asking. We
Yeah.
just we have drop-in peer tutoring. I think we used to have 5, 10, 15 students every night, and now we see maybe 2 or 3 students a week.
Hmm.
My office hours, same as Shannon's, used to be so well subscribed, and it's much less now. So same problem. And I think, Michelle, your idea of a rebrand is kind of genius. Like students who do come to office hours find them so helpful, and then the word kind of spreads gradually over the semester. But I think the ways of advertising that would be actually kind of smart.
So is everybody doing in-person office hours or Zoom?
I've
Mine are
tried
in
both, but
person.
the Zoom ones were not attended.
Oh, okay. Kills that hypothesis.
I do mostly in person unless the student requests it explicitly.
Same.
This is a
I
whole
make
new
it an
concept
option
for
so they
us.
know that they can request it, but most students choose to come in person.
Yeah, we don't have office hours in the UK or in Europe. We don't do that. We tend to do what your rebrand is, Michelle. We have a built-in workshops for feedback into the talk components for all modules or courses.
Gregor, I see your comment about group office hours. We rebrand those as a study session or a review session, and they're very well attended still. So I do think some of it is like cultivating, like you don't have to come with a question, helps, and also like this is an activity and not like a one-to-one seems to help.
Also, spontaneous drop-ins improve if they see the door open and there are four students sitting and it's a more light-hearted conversation. Then I can
Yeah.
even get students writing on the board and trying things out with joking around a little bit. And then students seem to kind of congregate and listening in spontaneously.
I'll just add on to my comment in the chat as well. I find at least this, past semester, students were coming to my in-person office hours, having not even attempted a problem yet and saying, they wouldn't say it, but they wanted me to just write out a template. And so I have to help them unlearn that instant gratification that AI gives them of, oh, you just type in the problem, it gives you a template. And then we would
Yeah.
see on exams, the template doesn't work, right? You have a misunderstanding of the chemistry. You want a math problem, but this is a chemistry calculation. So, like for example, with buffers, they wanted just okay, first you do this, then you do this, then you do this, but they didn't actually understand the behavior of a buffer. So
Yeah.
that was a challenge. And that's what I mean about chemical intuition is, I feel my alarm bells going off in my head when I'm doing a calculation if something has gone wrong. I can just look at the numbers. But at the undergraduate level, and I'm sure I was this way too when I was a Gen Chem student, you don't have that feeling or that sense that, okay, this isn't right, or why is this calculation going this way?
Yeah, I've actually had a lot of luck giving them the math and asking them a conceptual question about every line of the math. But I see Kim nodding. That works really well when you have like 15 students. It works a lot less well when I think you have as many students as Shannon does. Even if you do have an army of TAs, that rapidly becomes really prohibitively effortful to mark.
It can be challenging too, and this is something that's unique to us potentially, but my TAs for my course are actually undergraduate students. We have very, very few graduate students. So I am sitting picking, the cream of the crop of my undergrads that have gone through the course to say, you could manage to TA this and make sure that you're pushing the level of detail that I want onto the course to make sure that this is where they learn that literacy of the lab. And, like Zoe said, the intuition of why do I need to dry this? Or can you stop drying that? What is the purpose of drying that? You're wasting time in the lab. This is where they learn all of that in our curriculum is at this second year level. So it's just such a heavy course for them too, that, I think they feel that cognitive load, the lab, the coursework, the everything, and, the little bit of offloading they do. You can't kind of blame them sometimes. It's a lot.
I hate to cut us off, but we have gone over. I'll say, I think this kind of conversation is exactly what Bhavik and I imagined when we wanted to start this, that there would be opportunities for us, people who wouldn't normally connect, who are teaching in really different contexts, not just locations, but the context that comes with them. So thank you, Shannon, for such a really great, thought-provoking talk that led to such a great conversation as well. And I'll just put in the chat one more time. If you're a subscriber, you don't have to keep registering. I'll send you the links every time. But if you're not, our next talk in August should be, I think, equally illuminating. So thank you so much, Shannon, and thanks to everybody for being here. I'll send out the recording later today.
Thanks for having me.
Thanks, Shannon. Great presentation.
Right.
I have to run to my next meeting too, but thanks.
Yeah.
That was fantastic. And I
Thank
agree.
you again.
I'm really excited to see the paper that comes out of this.
Yeah. Couple, I think.
Yeah, yeah,
It's a
definitely.
lot of data. Great.
And beautifully done. I loved the way you popped out at each revision. I thought that was like so intuitive and helpful.
Yeah, took us a while to figure that one out, and the graphics are all on Cole. He did a great job putting
They're
those
really
together.
nice.
They're
They're really
great.
nice.
Yeah.
Thank you. Enjoy the rest of your
Great.
summer.
You too.